Ukrainian demining experts to use his detector. The group was from the State Emergency Service of Ukraine. Waves and radar.
My father worked at a university, researching radio waves, antennas, and so forth. So, growing up, I was regularly exposed to those sorts of things. Also, making and flying radio-controlled airplanes is one of my hobbies. In that sense, I've always really been interested in the ways that we use radio waves. Back then, we didn't have tech like mobile phones, but radio waves were a part of my life, and I imagined the ways they could be used.
At university, Sato studied engineering and did research on radio waves. After graduate school, he became interested in using radio waves to survey features beneath the Earth's surface and started conducting research on ground-penetrating radar.
It's a very special kind of radar technology. Even just 10 centimeters underground, depending on the location, you have things like gravel, plant roots, moisture. That means radio waves can't travel straight through them. So detecting something 10 centimeters underground is harder than detecting an airplane flying 50 kilometers away. As a researcher, I found it more rewarding to pursue a specialized technology rather than a general one. So that was my focus.
Hoping to find wider use for ground-penetrating radar, Sato began developing a landmine detector in 2002. As part of his research, he visited countries that were dealing with landmine problems, such as Afghanistan and Cambodia. But the development process was not an easy one.
The biggest problem was the disconnect between developing landmine detection technology in the lab and figuring out how to use radar in the field. There's a considerable discrepancy there. The difficulty of imaging buried objects varies tremendously depending on soil conditions.
Sato collected a wide range of data so he could make a detector adapted to many different environments. In 2017, after 15 years in development, it was finally ready. The tech is now being used in 4 countries, including Ukraine. In Cambodia, the devices have helped deminers find over 200 landmines to date. In February 2023, Japan supplied 12 more of Sato's mine detectors to Cambodian authorities.
I've been visiting Cambodia for many years now. I've seen some of the sites they've cleared of mines. 6 months after removal, that land is being used for things like rice farming. It's really gratifying to be able to see the visible effects of mine removal. Demining efforts are a way of providing support to the people living in these areas. Being able to help out in this regard is something that really makes me happy.
In June, Sato received a visit from the Colombian Army's Humanitarian Demining Brigade. They were considering implementing his detectors and wanted to see what the technology was like firsthand.
Estoy sacando un dato. Por el detector de metal supe que ahí tiene un metal. Ahora empiezo a sacar datos.
This こんな風にして、絵を撮ることができるわけです。
The members of the brigade got to try the device out for themselves. The response was positive, and they expressed interest in moving discussions forward.
The challenge in Colombia is that we have very little information on what kind of mines insurgents have used, and additionally, how they're buried. So our thinking is that by using a radar imaging system, they can see the shape of buried explosives before they start digging. If they can get a sense of the mine's parts and function, that will mean they can dig it out in a safer way. So that's what they're interested in right now.
Don't evaluate the time for operation, so I want to ask you to do it very carefully.
In July, a second training session for the Ukrainian demining experts took place in Poland. In the previous session, they'd learned the basics of using the detector. This time, they learned how to manipulate it to display accurate images on screen. The team made significant progress as they worked toward full-scale implementation.
They're now able to properly apply the techniques they've learned, as well as discuss technical issues. That's been the biggest gain from this past session. Right now in Ukraine, they're only using 4 of our mine detectors, so it's not a full-scale operation. It's still a trial. The plan is to ramp that up moving forward. Right now, we're preparing to send 50 more of these to Ukraine. Once those are implemented in the field, they can begin full-scale mine removal efforts with our system. What should be done now? Let's say, for example, that you have a piece of equipment, an apparatus in your laboratory that they don't have in other labs. What can you do with it? What can you alone do with it? That's the kind of thing I would always think about. When deciding a course of action, consider what you can do at this moment. Instead of just going with current trends for no particular reason, take a different point of view. That's what the world needs.